Okay, example 2. Simplify each expression by writing it in terms of cosine only. So we want to take the expression I'm given and rewrite it so that it's only cosines if possible. Sometimes it won't be possible, but in this case it will be. So I want to take the expression sine theta times cotangent theta, and I want to change it so that it says all cosines. Now, I don't know if it's going to end up with 2 cosines or 1 plus cosine or cosine squared. Whatever it is, it's got to have only cosine in it. Well, I'm going to look back at the sheet up here and see if there's anything that can help me with a substitution that changes sines and cotangents into cosines. Well, it may not go directly all the time, or maybe you have to get some other things in there first, but sine itself, I just don't see a way to change sine into cosines just straight outright. So maybe I can deal with cotangent. So look here and I see, oh wait, okay, this cotangent here has a cosine in it, so at least I can get rid of the cotangent and have a cosine in its place. So I'm going to swap out the cotangent and put in its place cosine over sine. So back down here, I'm going to go and write this, try to hold the camera right. So that becomes sine of theta, and I replace the cotangent with, well, cotangent is cosine over sine, so cosine of theta over sine of theta. All right, well, this sine is understood to be in a numerator. So I know that it's over 1, and since it's on the top and that one's on the bottom, they will cancel out, and I'm left with cosine of theta. I've simplified it to have just cosines. Yay, done. Okay, try another one. Okay, this one says cosecant squared of theta minus 1 times sine squared of theta. Okay? All right, well, there's that cosecant squared, and I've got a 1 with it. Whenever I see one of them squared with a 1 with it, I'm going to go immediately look at my Pythagorean identities. Okay, so it had cosecant squared. Where's my pen? Cosecant squared. So find the cosecant squared is this one up here. Well, cosecant squared is 1 plus cotangent squared. Okay, well, let's see. If I want to end up getting sine or cosines, I know I can get cotangents to turn into some cosines, but what am I going to do, with the sine? I've got to do something else here. Well, another thing I could do, I could try distributing. So why don't I distribute this and see what happens? And so if I do cosecant squared times sine squared, when I distribute across, it'll be cosecant squared theta times sine squared of theta. That's this multiplication. All right? And then right there is minus sine squared of theta. Okay, so we see what I did. I did sine squared times cosecant squared, there it is, and sine squared times 1, and there it is. Okay, well, what's the relationship between cosecant and sine? You don't have to write it out this way, but let's just spell it out a little bit at a time here. Cosecant squared is cosecant of theta times cosecant of theta. All right? And sine squared is sine squared times sine. But each one of these are reciprocals of each other, so if you want to swap those out and call them 1 over sine and 1 over sine times sine, they will knock each other out and make 1. Oops, I forgot to bring that down. That's got a minus sine squared over here. Minus sine squared. All right, well, that all cancels out and makes 1. So I'm left with 1 minus sine squared of theta. But there's another one, so I'll look back up here. If I take that sine squared and move it over there, I'm left with cosine squared equals 1 minus sine squared. So that is equal to cosine squared of theta. And we are done with that one. Okay. Okay, now for the fun one of the day, and the last one. We're changing this into all terms of cosine still. So it's 1, the expression is 1 plus sine of theta over cosine of theta plus cosine of theta over 1 plus sine of theta. Be very careful because 1 plus sine of theta looks like it might be a Pythagorean identity, but it is not because it is not squared. See, the Pythagorean identities have the squares. They're all squares. So this is not a Pythagorean identity, and I can't get any magic tricks out of that. So I want to convert this to all cosines. Well, what are you going to do when you've got something like this? I've got a fraction plus a fraction, and there's no straight substitution I can do to change sines into cosines. It's not a Pythagorean identity, so I can't make that switch. I've got no choice here. I'm going to have to add these two ugly fractions by getting a common denominator. Okay, so let me use a different color here. So this fraction has a denominator of cosine, and that one does not. So I'm going to multiply this fraction, top and bottom, by cosine of theta and cosine of theta. That's a value of 1. I'm allowed to multiply by 1. It doesn't change anything. Over on this fraction, I'm going to multiply by what I've got in this denominator. This denominator has a 1 plus sine theta, so I'm going to multiply that over here. So I'm going to multiply top and bottom by 1 plus sine of theta over 1 plus sine of theta. Sorry, it's messy. Okay, go back to blue. Well, what does that do on top? Well, before I sort out the top, my denominator is 1 plus sine times cosine, and 1 plus sine times cosine. I've got a common denominator now, and that common denominator is 1 plus sine theta times a cosine of theta. Okay, that's theta. But my numerator is going to be a little more ugly, so I FOIL method the top. 1 times 1 is 1. All right, 1 times sine, and 1 times sine, it becomes plus 2 sine thetas. Careful, that's not sine squared, that's sine plus sine. And then I've got sine times sine, which is plus sine squared of theta. That's all this fraction. All right, let's extend my fraction line here. And up here, that one's not going to be so bad. That's going to be plus cosine theta. Right? Okay, so cosine squared of theta. Okay, what can clean up here? I know that there's some squares here, so, and they're all sines and cosines squared, so it looks like I can probably squeeze one of these guys out. So if I take the sine squared plus cosine squared, these two right here, I can replace it with a 1. All right, so let's recopy all this line, draw the line here. Okay, so this 1 plus 2 sine of theta plus, okay, those two, sine squared plus cosine, that's equal to 1, so it's plus 1 here over my denominator of 1 plus sine of theta and a cosine of theta. All right, this will clean up. I got a 1 plus a 1. Hey, there we go, something easy for a change. So I now have 2 plus 2 sine theta over 1 plus sine theta times a cosine of theta. Sorry. Can I do anything up here? Well, I hope you see it. I can factor out a 2. So let's factor out a 2. So on the top I have a 2, and inside it's a 1 plus a 1 sine theta All right, see that multiplies. 2 times 1 gives me the 2. 2 times that gives me that. And my denominator is a 1 plus sine theta and a cosine theta. Well, there we go. That guy cancels that guy, and that's a 2 right there. And then my final answer is 2 over cosine theta. I've gotten as far down as I can. There's no other trig ratios in there besides cosine, and I can't do a thing about that too. I have accomplished the task. We are done with example 2, part C. All right, I wish you luck. I will post the assignment sometime tonight or tomorrow morning so that you have it, and I will post these videos. Hopefully that'll work. Have a great day and a great weekend.